Hey everybody, before we get started, this is Future AJ. I just wanted to say we had some internet issues during this recording. We lost the high resolution version of the files, however, we had a backup. For the most part, the audio is fine, except in some places, Harrison's audio connection gets a little robot-y. We lose Harrison's video at the end, and throughout the whole video, the video resolution is a little bit potato. But it's good enough for a podcast. Sorry about that. Some days, I guess the internet just doesn't cooperate. So enjoy the show. Hey, everybody. Welcome back to the 83rd episode of Taps and Patience. I am AJ with Audacity Micro, here with Harrison of Precision Ingenuity. How you doing, Harrison?
Oh, per the norm, exhausted, and had a long week that ended on a high note because I got everything done.
That's good. Yes. Wow, it is like the end of the week, isn't it? It's Thursday. Yeah, it's Thursday. I should take out my trash today. I was trying to remember what I've done. Okay, yeah, I've done a couple things. I, for the most part, have had a relatively chill week. I had a bunch of kind of smaller, simpler parts. The one exception was an incredibly frustrating moment where I was finishing up a part. It was a super simple Xometry part. It was one of those that I grabbed basically just because I could knock it out in like 45 minutes and help kind of pad my score a little bit. And it was going well. Everything was doing fine until the very last operation, which was I did the majority of it with an 1/8 inch tool, and then I came back in with a 1/16 inch just to like do a 2D contour and kind of clean up finished a face that I couldn't get with the 1/8 inch because it had some tighter corner radiuses. So basically, it was just doing those corner radiuses. That's what mattered. And it cut too deep and it cut way oversized.
Ooh.
It was like 5 thou too deep. Like you can see the tool mismatch. And I was like so confused because it's just a 1/16 end mill. I've used this thing plenty of times. Like now, and because it cut too deep, I was able to measure that groove, and it cut like 75 thou wide when it should have been like 0.63.
Interesting.
So I was trying to figure out what the heck happened. I remeasured the tool, and the tool length was too long, as you might expect. And I just kind of spun the tool holder like in the spindle, and I could see visual wobble in it. A chip got stuck on the taper when it did the tool change.
Oh no.
And so it gave it run out, which made the tool effectively a bigger diameter, and it made it longer. I was so annoyed. It would have been such a quick, easy part if it weren't for that. But because of that, I had to drive to the airport to go drop off that and like 2 other parts that I had to drop off at the same time.
Interesting.
So that one stupid part made me drive 2 hours because of one stupid little chip that landed in the wrong place at the wrong time.
Yeah.
So that was annoying.
I'm always scared with my through spindle coolant that a chip's going to go through that through spindle coolant and then be on one of the faces whenever it does a tool change, which is very likely to happen. So I need to do a really good job of filtering that out before that happens. Which, to the best of my knowledge, it hasn't happened yet. Or if it has, it's been small enough effect that it hasn't scrapped any parts.
Yeah, I think with your machine, your drawbar force is so much more significant than mine, where yours is more likely to just squish the chip and or embed it in the tool holder. Whereas on mine, which only has, on a good day, 300 pounds of drawbar force, it's more likely to cause weird issues.
That makes sense.
I have no idea how you prevent this on a umbrella style tool changer. Like, there's no blow off or anything, I don't think. If there is, it's not working.
The Tormach had blow off.
The Tormach had blow off.
So, I mean, you can have, you said on umbrella style machines, so you can have it on umbrella style machines. The Haas compact mill might not.
Yeah, I don't know how you're supposed to prevent it on my machine, I guess would have been the thing to say.
Yeah, that is a good question. Now, the one thing that Haas has over the Tormach is that the umbrella should be sealed all the way around, right? Because it's got, anytime there's an empty pocket, there should be a metal shield that comes out, preventing chips from getting up on top of everything.
No, mine definitely does not have that.
Oh, really? It doesn't?
Yeah.
I think the larger machines have that.
I understand why.
So
it may even just be the newer ones having it because mine's old.
That could be too. I wonder if you could retrofit something like that or get a version that, if the new CMs have that, I wonder if you could get a new disc that had those auto close features on them. Because all it is it's just like a piece of sheet metal on it with a spring that when the tool goes in, it pushes the sheet metal back and then it grabs on. And then when you pull the tool out, it close. In fact, I think the mini mill, and I think the reason I know this is the mini mill at the university that I teach at sometimes. I think it has that.
Interesting.
And it's
that'll definitely be better. I've been meaning to take apart my tool carousel and just like clean it really good. That's like the one last thing. Yeah, I have another maintenance issue to talk about. But the tool carousel is still super, 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 super dirty from the previous owners. Like all the screws are rusting out. There's rust on some of the fingers. It still has some of that like ceramic gunk on it, and it just really needs like a good cleaning.
I thought you pulled that out and cleaned it already.
No, I never did.
Oh, you just used it enough that they started working good.
Yeah. And actually still I'll occasionally have it drop a tool because one of the fingers has come loose.
Okay.
Before it was dropping tools because the fingers were too tight. And I think in some cases, like basically the gunk glued the fingers to the carousel. And I think in other cases, it's like the screw gets glued to the fingers. And so when you activate the fingers over and over again, that screw slowly gets backed out. I think that's what's happening. So
makes sense.
Yeah, it just needs TLC.
Yeah, and being it's your main machine, you don't have a whole lot of time to take it down and do that TLC.
Well, this week happens to be a very good week for maintenance.
Oh, okay.
I have a couple small projects, but like I officially signed that contract with NextGen to do their Fusion course. So over the next week or so, I'm primarily like a full-time YouTuber, basically. I'm just recording videos for them.
No, that's good.
Not that the videos are actually going on YouTube, but
yeah. So does that mean you'll be able to take care of your other major maintenance problem?
That is kind of the plan. I need to get those bearings ordered. So what Harrison's referring to is the other day, I don't even remember what caused me to do this, but I just kind of like, oh wait, it was the it was the tool holder chip issue. That's what caused me to do this actually. I went and I just like wiggled the tool holder and to see if it was like on a chip or something like that. After like I took the tool holder out, I cleaned off the tool holder, I cleaned the taper, I put the tool holder back in, and I gave it kind of a wiggle. And I noticed that there was play in my bearings, which this machine has never had particularly good finishes. I have blamed it in the past on my mod vise was one thing I used to blame it on because the finishes were bad specifically on the back of my parts when traveling in X. That's where they were where they were the worst. And then after that, I was blaming it on drawbar force, but I borrowed the tool from CNC Repairman and verified my drawbar force is actually slightly more than spec. And then I feel like I had one other bad excuse that I was making, but it's the spindle. So the bearings are shot. It is still running, and it does pretty good as long as I'm using tools that don't require much tool pressure. But if I use anything bigger than like 1/8 of an inch, my finishes start to get bad.
Gotcha.
So bearing replacements are in my future.
You gonna try to do it yourself, or you gonna outsource it, or are you still undecided?
Yeah, I sent like one RFQ on a whim to a place that was in Chicago, which is like 3 or 4 hours from me. And they got back to me pretty quick. It's going to be like $2,100 and 7 business days with them, which isn't the end of the world. But the bearings themselves are about $300, and I've done bearings before. I do still have 2 other RFQs out with different companies that are actually they're in Indianapolis, so like less than an hour away. And I'm curious what they're going to say. Honestly, if they were cheaper and or they had better lead times, I would probably just do that. But I think I can do the bearings myself. There's a Robin Renzetti video on it. Like, it seems doable. I've done it on the Tormach.
Did I do it on the Tormach? I did it on the Tormach.
I did do it on the Tormach once, yeah.
Did you replace the bearings or did you just open it up?
At one point,
because you opened it up because you opened it up because you had a bolt that had backed off, but I didn't think you replaced him because it was a new spindle. I don't think you actually.
Okay, fine. I haven't done bearings. I've taken it apart and I've put it back together again. You're right. I never actually removed the bearings.
That's right. Well, I didn't know if you did it on a different machine, but on that one, I think it was just that loose nut.
Yeah, did I do it on the? I did stepper motor bearings on the Pocket NC at one point, but that's a different animal.
I think I've done all the bearings on my Tormach at this point. I've done
the thrust bearings.
Yeah, I've done the thrust bearings and I've done the spindle, and I've got a new spindle in it. So
yeah,
the old spindle that I rebuilt lasted about as long as the original, and I never felt like it. I felt like it kind of robbed a little bit of power on the machine, the one that I did, and I don't know if it was just I had a different type of grease or what, but it just felt like it didn't have quite the same amount of power, like maybe 10% less power or something.
I wonder if you like put too much preload on it or something.
That could have been too.
Which would have caused more heat and friction and killed the bearings earlier.
Yeah, very possible. So, I don't know. We ended up just replacing it with a factory spec one, especially because the new ones came with sealed bearings. So, that was the main reason we went with the factory one. Because I didn't want to get when I did it originally, there was that one guy that had done a video on the replacement, and they were opened, and it was pretty common knowledge, at least, that the early MX spindle bearings, if you ran at 10,000, would go out pretty fast. And so I just wanted to try to get something in there that was better, which is the main reason I rebuilt instead of buy the first time. Second time, they had already replaced the bearings, and it made sense just to buy a new one.
The Haas bearings, because the ISO 20 spindle is so small, I believe it's actually cheaper to get high-quality bearings for the Haas than it was to get bearings for the Tormach.
That could be.
Because it's only $300 for, like, nice bearings. Like, super precision, above ABEX 7.
Yeah. We got eBay bearings because the cheapest quote we could find for the good stuff was like $1,400, and I didn't want to risk rebuilding it on those and then having it get trashed too fast. So I bought some eBay genuine that I'm not sure are genuine bearings, but they did fine.
How much were those?
They were about $300 total.
Okay.
So, or it was either $300 total or $300 a piece. I don't remember. I want to say 300 total. I want to say they were each 150 each set.
Did you get it? Did the bearing or the Tormach have 2 pairs of bearings?
Yeah, it had 4 bearings. It had
okay.
It had a lower thrust set and a higher thrust set that were different diameters. So,
I believe the Haas only has 1 pair of bearings
on top. Oh, really?
Mm-hmm.
Interesting.
1 bearing on top, 1 bearing on bottom, separated by a spacer.
No, okay. It could be because of the higher RPMs, less friction.
Yeah, I did have a hard time finding bearings rated for 40K RPM on grease, which is theoretically what the spindle is. Though it looks like we get into some of the problems where my machine's a unicorn. So the spindle is originally grease packed. It uses a grease packed spindle.
Mm-hmm.
At some point, some of the hot spindles for the OMs were converted to oil. And so I assume that means that it doesn't have any grease in it anymore, right? It
So
just has that oil feed.
My machine is an oil machine, and I didn't realize that when we got it. And so anytime the spindle's running, you'll hear a hiss of air, and it's dripping oil into that airstream. And so there's constantly air blowing out around the spindle taper anytime it's running. And for like 2 minutes after the spindle stops, it'll keep spewing, and then it'll stop. And like the first time it did that, I asked the tech, I'm like, is that thing leaking? Is there something broken? And then he had to explain to me that it was not grease packed, but an oil reservoir, and that it was supposed to do that. And I was like, oh, cool. So
I guess I'm sorry, I'm kind of processing through some of this stuff for the first time. I guess I know that it was converted to that oil because I do have that oil reservoir and it does blow air through it. I'm not 100% convinced it is actually oiling, which maybe that's why my bearings died. Because or maybe it just doesn't use very much oil, but I have never added more oil to it, and it does not look like it's used much, if any.
My new machine, they said it should last like 3 or 4 years before I need to add oil.
Okay.
And that's in a full...
it could be either way.
Yeah, that's in a full production environment. And like, he showed me the thing while it was running. He said it'll do like a drop of oil like once a minute, or if that, out of the reservoir when it's running. And so it's so little. It's just enough to like, make sure that it stays wet. It's like basically it's supplying enough oil to replace any that might come out during operation is basically what it's doing.
So I shouldn't need to buy grease and grease pack these bearings, right?
If you've got the air stream and the oil reservoir, no, you should not. In fact, adding grease would make things worse.
Yeah. So I should probably just like suck up a little bit of grease out of that tank a little bit of oil out of my oiler tank and just kind of lightly coat the bearings, you think?
Yeah.
Okay.
Yeah. That's all you would need to do.
I can do that.
I might over lube them as much as you can with the oil just to make sure that they've got plenty. And I would make sure I would take off the airstream that's going to your spindle and put it on like a white sheet of paper and just let it sit there for a minute or two and just see if it gets wetted. Because if it gets wetted, then you'll be fine. It's still working. If it doesn't, then you got a problem with your oil supply, which could be what caused your bearings to go out.
Yeah. Let's see. I know. No, I was gonna say I know I have some constant air purge, but it's actually I don't know if it's a constant air purge. I know I have some air purge during tool changes, but that's actually provided by the drawbar. That'd be a completely different system.
Do you get any water in your airlines?
I haven't until this year. I don't know what's going on this year, but this year I am seeing water.
Because if you're getting water in your airlines and it's constantly blowing air through your spindle,
could have water in my spindle.
Water and bearings do not go together.
Yeah.
Just as a thought. Especially if you're not getting oil and you're only getting water at that point.
Yeah. That should be fairly obvious when I open it up. Man, I hope I don't like open it up and find some.
Yeah, but that's my biggest concern
of it. But
that's my biggest concern with your air is I had that piston compressor at my old shop, and I swear that thing produced water and I had like 4 water separators that would all fill up, and I'd have to drain the tank once a week. I mean, it just had so much water, and thankfully, our lathe was the last thing on the loop, and so it saw the least amount of water out of any of our equipment, thankfully.
I swear I have never seen water in our airlines until this spring. And I don't know what it is about this spring.
Do you have high humidity?
Unless it is like my filter separator thing is shot. Maybe that's the problem with the water.
Have you had a lot of rain recently?
It has been wet.
So,
but I've had
around here, you get a lot of air in your systems during this time of year, just because of how much it rains and how much water gets in the air, and I mean, the air compressor just basically creates water from air at that point, like crazy.
Yeah, these are all things I need to work on.
So, yeah, I would recommend doing something, because if you do have air going to your spindle, you cannot have water in that line. Otherwise, you will have problems no matter what you do going forward, whether you fix it yourself or send it in. That can't happen.
Well, maybe I buy an air dryer.
They're like, you can get a good one off, like a Harbor Freight one, which is the one we almost got at the old shop for about $500.
Yeah, it's, according to this, is $600.
It might have gone up in price. That was probably a couple years ago.
But growth each cast for breakfast.
Yep, it does. Me and Weston are dealing with that right now because we've got a couple people interested with our Tormach. We've had a couple offers, and they're a little lower than I'm wanting to accept right now. But if push comes to shove, I might. But we need to get another machine in because our bottleneck right now is the new machine, and it's so awesome and so efficient, which is great. But we're also getting a lot more work, and it's getting overloaded, and I don't want to put any of that work on the Tormach. I put as much as I can, but like I'll get a part and I'm like, I could do that on the Tormach, but if I can go fast enough, I don't need to. And so that's what I've been doing.
Yeah, I would just sell that thing for whatever someone's offering right now, because I think prices on those are only going to go down as more 1500s get into the wild, and also opportunity cost.
Yep, we've been having that discussion, and we'll see. It might get sold here relatively soon, but we'll see. We definitely need a second mill. Although it's been interesting, I've been talking to a lot of people in the industry, and there's a lot of shops in our area right now that are just flat out dead. And apparently, this is my first time being in the machine shop during an election year, but apparently this is a pretty common occurrence for election years. Election years, usually stuff dies down because everyone's waiting to see who's going to get into office, and then right after the end of the election, as soon as they know that someone's in office, whoever it is, like it goes gangbusters.
Yep.
And so that's what I've been hearing a lot of. I don't know it from lived experience, but I definitely see it in the amount of shops in the area that are all dead right now. Like I had a salesman that came in today, and he was telling me about a shop that had about 20 machines, and they said they only had probably 2 or 3 spindles running. They said we were basically producing as much as they were with our small shop right now. So and unfortunately, I've heard that from more shops than I've heard that from multiple shops in the area, which is, I guess, why I should be excited that we're still swamped because we're still busy. But it doesn't take much for us to get super busy, so there's that too.
It's a good argument for keeping a shop smaller. Like, I'm going to use that as my argument. One of my arguments for keeping my shop small, kind of intentionally, is, if it's me and, one machine or 2 machine payments, like I can just take Xometry work if stuff slows down.
Mm-hmm.
But if you're trying to run 20 machines, like, it's a lot of Xometry work.
Yep. Speaking of Xometry, I do have some news on that front. We got ITAR certified.
Ooh. So well, that's awesome.
And we just got approval Wednesday or Tuesday this week for ITAR jobs on Xometry. We haven't accepted any yet. We're still we're certified, and we've got the approval on Xometry side. All the paperwork's done, but we're a little hesitant to take our first ITAR job just to make sure we don't mess anything up with the requirements that are around those jobs. I'm sure it's going to be pretty easy and standard once we kind of get the hang of it, but we're trying to be very cautious and careful with our first one just to make sure we don't, do anything wrong. Because
so what goes into that? Like, walk me through the whole process and what it gets you.
So I honestly couldn't tell you much because Weston's been doing most of this work in the background, and he's been working on it for about a month. But my understanding is there's a lot of stuff you got to fill out on the government side, and then you got to pay some money, and then you get a certificate, and then you have to stay up to date and pay for it basically every year. It's like a license, and you have certain requirements you have to meet. And if there's ever any question that you've fallen outside of those, then an audit can be called of some kind, I believe. I'm speaking from this with zero authority, but that's my understanding. And basically, you got to, as long as you're in code or don't stray from the rules, you're fine. And it sounds really complicated, but it's basically, like if you're using a VPN, it has to be a paid VPN. You can't keep anything on clouds. So Fusion and OneDrive, you can't do that. You can use Fusion, it just can't be connected because that's what Servin Solutions does. Is he leaves it disconnected and stores everything locally. And so there's just a lot of different things that you got to be aware of. But I will say that I've only seen 5 or 10% of the job board with ITAR jobs on it so far. And they have been a lot higher dollar amount, but they're also a lot higher complexity, and quantities are all over the place. So
okay. So jobs that you want in the future, or jobs you don't want?
I'm not sure yet. I definitely jobs I'm interested in. This was not an ITAR job. This was before we got ITAR certified. We had a Xometry job. What? Oh, sorry.
I'm here.
Oh, okay.
I'm good.
I thought you said something.
We're good.
We had a Xometry job that came across. It was basically, it would have kept us busy for a week and would have more than equaled our weekly goal. It was about a $12,000 job for 200 parts of the same thing.
I've not seen a $12,000 job on Xometry before. No, that's not true. I have, but it was like a, never mind, distraction.
It was a $12,000 job, and Weston was like, "Oh man, what's the catch? What's the catch?" And it was like an L bracket basically, and it was a perfect 5-axis part, and it wasn't complicated, and it was just like, Weston's like, "I need you to come over here and look at it." And so we're looking at it. We're like, "What's the catch? What's the catch? What's the catch?" And we're like, "Go for it, go for it." And as soon as he goes to click on it, job's gone. It's like, no.
Oh, no. I did that on one the other day. Yeah, it's the worst.
So, excuse me. So Weston was just freaking out, and I was just like, "Oh my goodness, I wish we'd gotten that job so bad."
Yeah,
there'll be more, but yeah, that was we don't watch Xometry close enough as compared to most other shops, and so I'm sure there's a lot more opportunities like that pass us by that we don't even know about, just because we're not on there 24/7. We're like, if we get slow, which we haven't really been, we'll get on there and watch it pretty close, but we've been so busy that we don't really focus on it very much. We tried to set a goal of going through the board once a day and making sure that we clear everything off. So
I almost screwed myself with a Xometry job the other day. It was one of those where, like, okay, so basically every job that I take, I offer more money on. I very rarely take one at face value.
Mm-hmm.
And my strategy for that is, like, I'll just go through my job board and be like, $500, $1,000. And I don't always look at them super closely on my first pass through. And there was one that was like $150. It was basically just some like double-sided plate work. And I went, $500. And I came back, an hour later, and they were like, all right, $500. And the only reason I was looking at it more closely was because the lead time was kind of tight. It had like a day left or something. And I was like, oh, can I really do this? And I was looking at it closely. And as I was looking at it closely, there was the dumbest feature I have ever seen on this part. It was, I think it's literally impossible to machine. It would have required like a RAM EDM coming in through like into a 1/2-inch hole and then going sideways. It was just wild.
Interesting.
And it's like, I'm really glad I noticed that before I took the part, because that would not have been like, it literally would not have been possible for me to do.
Is it like a dimple in the side of the wall that you could have gotten with like a lollipop, or no?
No, it was
like a hole.
It was like a 1/2-inch hole that had a slot that was like, okay, so 1/2-inch hole in the wall. There was a slot that was like 1 millimeter tall and like 8 millimeters deep. So you couldn't even get it with like an undercutting tool because like the radius, like the aspect ratios just didn't work. It was wild.
Weird.
Yeah. It looks like someone designed it for additive manufacture and just like stuck it on Xometry. That's what it was, I think.
Could be.
So.
Oh, this worked out so good 3D printed. Let's get it machined.
Yeah, exactly. Just, hit the easy button and get a part.
Oh my goodness.
So I did machine some ceramic today.
Ooh.
That was fun.
How'd that go?
Actually, that was yesterday. Yesterday I machined some ceramic. Shockingly well. It was Macor, which is like a glass mica composite of some sort. And I was worried that it would be super, super, super hard, like zirconia or whatever or alumina, whatever that ceramic that you see like the guys on the Kern do. It wasn't like that at all. It was like really, really hard sidewalk chalk is basically how I could describe it.
Gotcha.
Or I think at one point I referred to it as a Tums, like a hard Tums. So it kind of left a white powdery stuff. It was relatively soft. I took an X-Acto knife and I was able to like scratch off some of the outside with an X-Acto knife. But it machined beautifully. Without much effort, it left really nice, like glassy smooth finishes.
Did you have to use like a special bit that looked like a deburr wheel or something, or like a
Nope, just straight up carbide end mills.
Oh really?
Yeah, I think if you're going to do production with it, or if the parts were big, these were literally like, I took the material I used, the stock was 3/8 inch diameter, and I turned it into like an 8 millimeter cylinder. Like I just made a big cylinder into a small cylinder. And so I had very little material removal. I think if you're doing a bigger run or a part with more material removal, you would want something like a diamond coated tool. I did see I saw either tool wear or thermal growth over the course of with scrapped parts. I made about 10 of them total, and I saw probably 2/10 of wear. But the other nice thing about this is it was like stupidly stable. Like I told the machine, hey, give me the 8 millimeter cut or whatever it was, and it gave me the 8 millimeter cut. And there was no taper, there was no like movement in the material, there was nothing weird. It just, I don't know.
I wonder if that's because unlike metal, whenever it cuts, it has some it can absorb it and push back. I wonder if with that material, because it kind of fractures on the micro level, that any deflection basically eats itself parallel basically instantly, because it all cracks away. There's nothing left to push against.
That's very possible. I think some of it is just a machining forces thing. Like it was soft enough that it just didn't provide force on the tool to deflect the tool.
Yeah. Yep.
Like imagine machining a crayon.
Yeah.
Like it's not, you're not going to get deflection on that. So, when I was Googling for speeds and feeds and like looking around, and I ended up calling Harvey, the internet says to do it at 25 SFM. which is very slow.
Mm-hmm.
Harvey said to run it at 600 SFM. Though that was with their diamond tooling. So I split the difference and just kind of used my titanium speeds and feeds with a a slower feed per tooth, a shorter feed per tooth. And I don't know, it seemed fine. I think it would be fairly forgiving as long as you're not hitting it so hard that you're like chipping stuff.
Yeah. But causing it to dissolve.
It was a very satisfying material.
Did you like vacuum it up?
Yeah, so I did it no air blast, no coolant, just nothing. And then when it was done, I would use a paper towel and I would wipe up as much of the ceramic as I could, and then I would come in with a shop vac and suck up anything that's left. Really, again, I was removing such little material that it did not matter too much.
So I had the opposite problem this week. I removed a ton of material.
I mean, that's very typical of our two shops. I'm over here like, wow, it was a big day. I removed a cubic inch. And you're like just filling up trucks with chips.
Yeah. We ran the biggest stainless steel parts, especially by weight, compared to anything we've ever run prior. It was 54 pounds of stainless. That by the time we were done with the part, it was 12 pounds. So it was about 42 pounds of stainless removed.
Gosh, that's a lot of material.
Yeah, and so it was pretty stressful. The first part took basically all day to do, and I had all kinds of problems. I had my part deflect because it was removing so much material that it kind of bent up. I had tools that pulled out. I had tools that broke. And it was basically at the minimum spec in several areas. And in some areas, I didn't quite get it all the way cleaned up. And anyways, it was a pain. And then the second part, I got machined in about half the time, no broken tools, and came out perfect. And nice. So did a lot of learning on that first part. And we got to get our tooling figured out for that heavy of material removal.
Was it mostly speeds and feeds, or?
It was some speeds and feeds, some figuring out the right tool for the job. We've got a 1/2 inch cutter, a 3/8 cutter, a 3/4 inch cutter, a 1 inch cutter, and playing around with feeds and speeds, trying to get the best tool life, and reliability, while also making sure it's not going to take a month to machine. And so trying to balance all those different factors. And like one thing that was crazy is that on the second part, I got up to 10 cubic inches of material removal, 10 MRR, with a 3/4 inch tool, which was just cool. It was just crazy. It was melting the material. It was so cool to watch. But it's still like the tool's fine, other than the corners are a little chipped, or starting to chip, and so I still got to play with some feeds and speeds on that. This is the same tool that I was struggling with on that really thin part a couple episodes ago. But now I'm taking a much bigger bite, and it sounded so much happier. Like it wasn't like on the first part, I had a 1/2 inch 4 flute that did the majority of the work, and it just screeched the whole time. I'm so sick and tired of 4 flute end mills. I don't think I'll ever touch another one again if I can help it, stainless. But I changed out to a 5 flute 1/2 inch and a 3/4 inch 5 flute 5 flute end mill, and both of those in stainless just hummed, and they did not screech, they did not shriek, they just ate the material, and were very pleasant to be around compared to the 4-flute. And I had the problem with the 4-flutes on the Tormach. On the Tormach, I used to run 4-flutes, and it used to screech and scream, and I switched to 5-flutes, and it never did that again in stainless. And so I don't know what it is about 4-flutes in stainless, but I hate them in stainless. So,
are you just not doing a big enough width of cut up with them? Because 4-flute's like a bigger width of cut than a 5-flute does.
It could be, but I tried running Haas's recommended, and I tried running Helical's recommended, and both of them sounded horrible. Haas's was half the diameter at 1.5 times D, and Helical's was the full length at like a 50 or 60 thou step over. And in both of those instances, it sounded horrible. In fact, Haas's sounded so much worse. It sounded like the thing was going to blow up. And so I could have made Haas's work had I slowed things down and done some tweaking, but it was going so slow compared to Helical's. And Helical's, while it was a screecher at a really high pitch, it didn't sound like the tool was going to implode and like the material was going to vibrate out of the machine. So, and then I switched to 5-flute, and all that went away. And it sounded like butter. It cut like butter. The machine was happy. I didn't want to hit my head against the wall listening to screeching all day. So, anyways, very happy with the 5-flutes. And so, yeah. And then we've had some tooling reps that have come in recently, and I'm going to be trying out some different tools from some different tooling vendors because I still want to get a good face mill in stainless, and that's really ticking me off that I don't have anything that seems to survive in stainless without going dirt slow. And I'd like to find out some. I've been using, like I said, the 1/2 inch and 3/4 inch tooling, and so far, like before, my default tool was a 3/8 inch tool from Haas, and now I've got a 1/2 inch version of that tool, and it's about twice the MRR or 75% more MRR than the 3/8 inch tool, and is sounding great. But when I jump up to the 3/4 inch tool, I'm not getting the same tool life, even though I'm running it basically in the same fashion as the other two. And so I'm not sure what I'm doing differently from the 3/4 versus the 1/2 inch and the 3/8, because the 1/2 inch and 3/8 they sound good and they last a long time. In fact, I haven't broken my 1/2 inch yet, or even seen any degradation in the tool quality. And I've been running it longer than the 3/4 at this point. So, but the 3/4, like I said, it jumps me up to, I think the 1/2 inch was giving me around 5 cubic inches a minute. I think the 3/8 was around 3 to 4 cubic inches. The 1/2 inch was 5 to 6 cubic inches, and then the 3/4 was up to around 10 to 11 cubic inches. And the 3/4, my tool life, I'd have to slow down the SFM or best with beads and feeds basically to try to get it to survive compared to the other two. Or the other two just eat it up.
I was having tool life issues with my ball mill on the carabiners because I surface in fillets.
Mm-hmm.
And I was using a ball, it's a 1/16 inch ball mill, and it was a fairly long one, like 1/16 inch, or excuse me, it was about 1/4 inch. So fairly long tool. And I fought that stupid tool for like 2 weeks. And then at one point I was placing a order for some thread mills to Online Carbide,
mm-hmm.
which, by the way, if you don't know about Online Carbide, they're like the best place to buy thread mills. They're so cheap and they work really well. But I like noticed they had some tools on there, and I ordered some stubby 1/16 inch 4-flute ball mills. Same thing, but stubby. And man, those work so much better than the other ones that I was running. And I think it's mostly because they're stubby. But I've been really happy with those. I went from like a $25 tool to like I think it's a $7 tool.
Oh, really?
And I'm getting better finishes and better tool life.
That's awesome.
So I've actually bought a couple online carbide stuff recently, and it's like dirt cheap, and I'm fairly happy with it.
Yeah. Well, so I keep having guys that are trying to sell us tooling that's, we've been using Haas tooling primarily, and I have a lot of guys coming in there bashing it and trying to get us to switch, and I'm all for switching, but if I can get, I think I did the math, on the primary 3/8 tool I've been using, I've been getting about 10 hours of tool life out of it, and it's a $25 tool or $30 tool. So it comes out to less than $3 an hour of runtime.
Mm-hmm.
And it's like, man, if you're selling me a $200 tool to replace that, it better last like a month before I have to replace it to make it worth it. I mean, it could be faster, and time is money. And so it's not all about, if I can get 10 times the work done in half the time, it's going to be better cost to go to that. But I have yet to have any tools last as long as that one. And that could be speeds and feeds and holders and stuff that I got to figure out going over to that more expensive stuff. But it's a lot harder to experiment with that more expensive stuff and figure all that out without breaking things. And I'm not sure I want to invest all that time and money without some validation that it's the right direction.
Well, at some levels, like, okay, sometimes you get an actual quality jump. If you go from like, you get an Amazon whatever end mill and you go to something like a Lakeshore carbide tool, like you're going to get actually nicer carbide.
Mm-hmm.
And it, not even to mention the grind. If you go from like Lakeshore carbide up a step, like you might actually get some nicer carbide still, and you're also going to get a little bit better technology thrown into that tool. But, then when you start going between like, Harvey and Sandvik and SGS, and it's like, basically at that point, if you're paying double, it's pretty much just covering like maybe a slightly fancier coating, but mostly just like consistency and like in support and service and stuff. Like you're not getting a whole lot more, technology or quality thrown in. Like it's just consistency and
yeah. And so that's what we're trying to figure out. I have no problem buying. I'm not loyal to Haas for their tooling or their machines. I like what I've used so far. There's very little that I've run into with any of our Haas stuff that I would complain about. But I would love to get better tooling and better stuff in here. I just haven't found anything that's blown me out of the water yet.
I know, what's his name? Dylan from Pronium gushes about the Frasia tools. Have you ever tried some of those?
I have not yet. I've talked to several of my sales reps about getting some Frasia tools, and every single one of them has been like, well, you can get the same quality for, a fraction of the price from this guy. And then at the same time, they get mad at me for using Haas tools because they're like, oh man, those are so cheap. And, you need to spend a little bit more money and get something nicer. And it's like, okay, well, what about the Frasia?
Yeah. So Frasia seems to be one of those companies that's actually innovating.
Yeah. So
like more than just incremental little, like we made the coating 0.01 mil sticker. Like they seem to actually be doing something.
I'll need to go see. I might have to just buy some tools from them just to try out. So I know that I would like to get some larger diameter tools and use the horsepower of this machine a little bit more, especially if I start taking on some more of these bigger parts. Because, going from, 4 or 5 hours of machining down to 2 hours, 2 to 3 hours is a big jump per part. So
I wonder where, like all machines have this, they have a tool size that they like really well.
Mm-hmm.
Like with the 1100s, it really like 3/8 inch tools. And
mine was 1/4 inch.
Oh, mine like
But is that anyway, for aluminum or stainless?
Quarter. I did not run much of stainless on that machine at all. So.
Then that'd be 3/8 would be good in aluminum.
Anyway, machines have sizes they like. My OM really likes 3/16. I get much better material removal with a 3/16 than I do a 1/4-inch tool. And yeah, it does not even like 3/8 at all. But with a 3/16, that thing can fly through material. And like, I don't know, your machine, it's a lot bigger. It's not a Tormach anymore, but it's still going to have limits.
Mm-hmm.
And like, it may just be happy with a 1/2-inch tool.
Yeah. I would say, based on what I've seen so far, it's going to be somewhere between a 1/2 inch and a 3/4 inch. It's probably going to be the upper limit of what it's happy with. Because I can run a 3/8 about like I used to run a 1/8 inch tool on the Tormach, where the machine wasn't really the limitation; it was more the tooling at that point. And so, but the Haas, like even running the 3/4 inch, my horsepower was only getting into like the 60s or 70s%. So if I have a problem, it'll be rigidity.
Yeah, so it's almost never horsepower. It's rigidity.
So, but the thing is it sounded smooth in the cut, and so
yeah,
that's what I got to figure out.
You may also just need to slow down and like just kind of like at some point the material gets to determine the rate.
Yeah.
Like you're back to my Venn diagram of the book I'm going to write someday, where like the material has its parameters, the machine has its parameters, and the tool has its parameters, and somewhere in between is your part. Like,
oh yeah, I understand all that, but I mean,
because I feel like you could have made more money if you ran that part at half the speed, and it went right the first time. So speaking of tools, maybe that's not a nice way to introduce them. We have Patreons, and we love our Patreons, and they're not tools. I would like to give a special shout out to Scott at Design the Everything, Jamie at JSpec Engineering, Chris at Zajic Precision, EJ at Nocturnal Welding, Simon, Chris from Thought Bomb Design, and Jake Brownson. As a Patreon, you get called a tool, apparently, and you get to that threw me off. If you are in the $10 a month tier, we get to read off your name every time. We have other Patreons who we also know and love, and they are at the $4 a month tier, basically $1 a show. So we appreciate everybody. All of the proceeds from the Patreon are going to getting Harrison and I to IMTS and our IMTS meetup, which will not be at the Pocket NC booth, but will still be on Monday. I got worried the Tormach might actually have a booth, and if they do, we'll go to that booth. Otherwise, we will find somewhere else to go. But if somebody, hey Norman, are you guys going? If you are, can we borrow your booth? If you would like to become a Patreon and help us get to that meetup and get to IMTS, there's a link down in the description. Speaking of descriptions, if you are watching this on YouTube, we also have a podcast of normal podcast players. If you are watching this in a podcast player or just listening to us, you can watch us in video, live in color, on YouTube. Also, Patreon, you get to ask us a question or two, or as many as you want. And this week we do have a question. It snuck in at the last minute. Right, like I think it was as we were starting recording. And nice. That is me stalling so that I can find it. Thought Bomb Design. Chris is asking, is the Pocket NC precise? I would like to make some very small parts with tiny features, and I'm wondering if it is better than a rigid router or a mill. I would say it is a mill. It's just a very small mill.
That's going to be for you, bud.
Yes, I'll go with this one. There's a couple things. It is a small machine. It is not servo driven. It is stepper driven, and that will give you some limitations. I would not try to chase anything under a thou for sure. You could probably chase a thou with a little bit of care and attention. particularly for things that you are doing without rotating the B axis or the C axis. Like if you're just doing 3-axis mode, you'll get very precise. However, if you want a like features on various sides to match up with each other, it takes a lot of calibration. And without a fancy probing program like Harrison discovered, that is rather difficult to get dialed in. So it comes from the factory pretty dead on because they do have the ability to probe it in. But once it gets to you, it'll slowly degrade. If you ever, crash it or whatever, you'll start to have like kinematic mismatch issues. It'll never be that bad, but expect to lose a couple thou of positional tolerances depending on the size and rotation of your part. But within a given 3-axis plane, it will be pretty good. And with their new controller, you can do I don't remember what the term is, but like the rotated work coordinate system stuff where you can set various work coordinate systems on various sides. The V210, that spindle is a little bit more forgiving, but more prone to run out and stuff. The V250, that spindle is awesome. It is super, super, super precise with super good run out. You have to like do warm-up cycles and stuff like that are a little bit headachy and you need an air compressor. But that spindle is awesome. And I think they have a new, like the CHB spindle or whatever it is, or CKB or CHK, whatever it is. That thing seems, I haven't used that one personally. I've used the V210 and the V250. I haven't used the new one. But from what I'm reading, people really like the new one even better.
Did you have both, or did you just have, which one did you actually have?
I purchased the V210, and then Pocket NC sent me a loaner V250 for a couple months.
Gotcha.
And they were both pretty cool. Like I said, the spindle on the V250 is awesome, but the kinematic calibration stuff becomes a little bit of a problem over time. But it's nothing you can't work around if you're careful.
Gotcha.
So I would say in 3-axis mode, it's going to be more accurate than something like a Nomad. And in 5-axis mode, you're, I don't know, maybe back at kind of similar levels of precision to that. But now there's the Solo, and that thing, theoretically, I've seen one in person. I haven't seen one run. I haven't tried to make a part on one. But theoretically, that thing should be like nutso precise. Like it's a baby Kern. It's got all actively controlled thermal cooling and stuff. Actually, I don't know if it's actively like heated, but it is like actively cooled at very least. So that thing should be super precise. I've been thinking more about one of those. The more I think about it, the more that might actually be a good next machine.
It could.
So, Penta, if you're listening,
you can try.
Yeah.
Coins.
I have the artwork for the coins. I still haven't sent it to Harrison. Let's put the cutoff at the end of the month. If you join the Patreon before the end of the month, you'll get a coin. Or if you have been a Patreon so far, then you get a coin. As long as you're active at the end of the month, you'll get one. So,
good deal. Got anything else?
I'm about to record a video. My most requested video is how to set up a Fusion Cam template, and so I'm going to do that. Oh wait, do we have another question? Ooh. Oh, we have another question that just 5 minutes ago. What strategies have you found effective for maintaining consistent production schedules?
Ooh. That's a good question.
I work until 3 a.m. sometimes. I'm the wrong person to ask for this. I do not.
This sounds like my question. So, in our shop, because there's 2 of us, we have to do a little bit more planning. And so typically the way our ERP system, if you want to call it, is, even though we don't really have that, is anytime we get a job, we try to print out all the information for the individual parts with a traveler, and then at each machine has a bin of jobs based on what we need to do next, and we try to group them as much as possible by material and then by due date. And so we just kind of stack them in there, and then I always know whenever I'm working on a job, if I've got a part running in the machine, I got some free time, I'll grab the next sheet and I'll work on programming that. And we do it by priority and by day. So we'll look out and we'll go, okay, we've got all these jobs, and we'll either sit down at the end of the day or at the first of the day, and we'll go through all the prints that we currently have. Especially as we approach due dates, we do this a lot more regularly. If we got plenty of time and it doesn't really matter, we might not meet and discuss. But when we get within about a 4-day, 3-day window of job dates coming due, we'll try to sit down at least once a day at the beginning or end, go through all the prints and be like, okay, we need to get these parts done by this day, these parts done by this day, these parts done by this day. And we try to stage it out and try to plan accordingly. And we'll look at the parts and we'll go, okay, looking at this part, it's going to take approximately this much time to run, this much time to program. And so I can get this part done, and this part done. And then maybe this part will bleed over into the next day. And so we've gotten pretty good at like planning out at least 2 or 3 days in advance what's the machine's going to be doing. And we would like to get an ERP system at some point. Weston is head over heels for ProShop and is drilling every time it comes up. And so that's probably the direction we're going to go at some point in the near future. But planning all of that stuff right now, we've been doing it via paper and via meetings. And we use Monday as the overarching scheduler. But each machine kind of has their own, like, we look at Monday to kind of see the jobs, and then we look at the machines to see the parts, because we might have different jobs mixed in on any particular day, but we look at Monday to see the main due dates for this particular jobs. If that makes sense.
That's Monday.com for the people wondering, which is a website.
Monday.com. Yeah, it's a website. And then we also have a label printer, and Weston printed out a whole bunch of labels of like job number, quantity, due date, material, operation times, deburring. It's basically it's a little sheet that we track our time on as a sticker.
That's smart.
And every time we print out a job and stuff, we'll stick one of those stickers on it, and we fill out the information as it goes through all the different stages. And so it's probably a 2-inch by 4-inch sticker that you can get like on those thermal printers that you use for printing your labels. He'll print off like 100 of them at a time in a spool, and then every time we get a job, we'll just peel off one of those stickers and stick it on the print somewhere, and we'll put the job number, due date, material, quantity, all that fun stuff, and then we'll track our time. How long did it take to do op 1, op 2, op 3, op 4, saw cut, laser engraving, sandblasting, deburring, like all the different processes. And then at the end, we'll look at all those and we use that for billing. And so, and if we've quoted a job, we'll compare what it actually took to what our quoted job is, and we use that to refine our quoting sheet over time. So, I'll bid a job, and we've gotten to the point now where there's been several parts that we've done, and we're within a couple bucks of what we bid. And so that's pretty cool whenever we quote something out and then we get the job done, and it's like, oh man, these are like really close. And then like there's other times where it's like, yeah, I missed that by like $400.
Yeah. I like to shiny the Xometry's job board and then panic when everything's due at the same time.
Yeah.
And then I work until 4 a.m.
We try to plan things out as much as possible, and then if we run into any scheduling problems, like, hey, we're not going to make a part by a date, I try to call my customer and be like, listen, we have this much capacity, this much time on these jobs. And so far that's only happened a handful of times. And every time that's worked out, the customer's been like, oh yeah, I need these parts for sure. Those parts I don't need for another 2 weeks. And so as long as you stay on top of it and can warn your customer of impending doom, they so far it's been a really good job of working around that, which is the downside to Xometry, that you can't really do that. Like,
but you can choose when you take the jobs.
Yeah, you can choose when you take the jobs, but if you run into scheduling conflicts later down the line, you're kind of hosed.
Yeah,
because you already agreed to it.
So Zach has 2 more questions. We'll skip the middle one and come back to it. So question number 3: how do you handle fluctuations in material costs?
So once again, we have a little sticker that we print out every time we buy material. And so if we are quoting a job, we look at the material we have on hand and we go off the pricing of any material we've bought in the past. And we've been blessed with that. All of our customers, even if they do repeat stuff, they very rarely go off of the original price, because they're varying the quantities and they're varying the due dates. And so usually we just build that in. We just need to get a price of what the material is going to cost for that job. And I try to factor in a percentage of it extra for scrap, even if if I'm doing one part, I might do like 1.2 or 1.3. I try not to do 2, especially on like the more expensive jobs. And I try to make up with that by charging a certain amount of overage on every job. That way, whenever I do actually need that, I have that built in across the board. But you can't always do that. Like the last job I did, like those big stainless parts, I only had 2 pieces of material. I wasn't going to buy a third, $400 piece of material in case I accidentally scrapped one of these parts. I had to make it work, from a time and material standpoint. And so, yeah.
For me, most of my jobs, material is 10% or less of the total job amount. So really, even if material changed by 25%, it wouldn't make a big difference. Also, most of the time, I'm taking jobs off of Xometry, and it's not a matter of like giving the customer a price. I'm just trying to figure out if it's worth it for me to do it or not. So material price doesn't really affect me there.
I will say, for us, we try to break everything down in cost per inch. And that seems to be the most efficient metric to put it in, because I can put that value in, and then I can say, okay, it's going to use 10 inches of material per part, and I'm doing 100 parts. I can figure out my total length from that, and I can figure out how many sticks I'm going to use. And so every single one of our sticks that we buy, we'll put a label on it, and it'll be like $4 an inch, 50 cents an inch, $200 an inch, whatever it is. It'll give us a per inch cost. And then whenever I'm going to quote that job, I'll put that per inch cost in a field, and then I'll put the length of a part in another field, and then I'll put the quantity in the third field, and it'll figure out my total length and my total cost of material for that job. And then I can add on extra after that if I need to or want to or whatever.
All right. And his last question: what are the key financial metrics you track to measure your business's performance?
So for us, that's our OPEX account. Mm-hmm. That's the one we have the biggest look on. So we've talked about it some on here. We use the profit first mentality. We've been doing it for a while. AJ's just now switching over to it. And basically, I try to make sure that my net 30 covers 50% of my business expenses in the next 30 days. And if I'm doing really well, then I have more coming in than I do. I have more than 50% coming in to cover all my expenses. And if I start doing poorly, that means one of 2 things. It means 1, we're spending money on things we shouldn't be spending on, or 2, we're not bidding the jobs high enough. Those are really the only 2 ways that we can fail, or if things are really going bad.
Or if you have too much work in progress. That's it. That's the one that gets me, at least.
Yeah, that's true. Because we could buy a whole bunch of stuff, and we have to pay for that up front. And so sometimes, like you said, we can get so successful that we're really short on cash until we finish up all the work. We've had that happen a couple times as well. But usually that all evens out in the wash. You just have to make sure you have enough. What I found is limiting your cash flow through the profit first method allows you to weather those storms better, because it forces scarcity, and it forces you to see problems sooner than you might normally if it was all in one big bucket.
Yep. So, everything you mentioned is a good one. I track well, it's not technically profit because I'm not including paying myself in this, but what I would like take home margin is what I tend to call it per job. So that is how much comes back into the business after cost of goods sold, basically. So materials, like job price minus materials plus tooling, is kind of the key metric that I look at. And I tend to sit around 75% coming back to me. Now, it's not true profit because I'm not paying myself for that, but
okay.
So the other metric.
Go ahead.
So that is not covering. So that does not differentiate between me spending 10 hours on a job or spending 100 hours on a job, which is something that I do not track, and I really should.
Yeah, you should. You really need to track that stuff.
I liked your time tracker sticker, so I wrote it down in my. It's my only note from this podcast. I might do that or something similar.
I was going to say, the only other metric that we track is the amount of cash flow or the amount of cash we generate per week. And, we have a goal of $6,000 minimum, or we have a minimum, which is $6,000, which is what we need to hit to survive, basically. And then our goal is 10,000. So that's our target is 10,000 a week.
Yeah.
So
I have an unofficial metric too. This is one of those, like, it's not, metric is a strong word for it, but it is actually a thing that I notice. So I do not buy brown paper in my shop. Like, I've never had to purchase brown paper at any time. It just comes to me in packages. I ship everything wrapped in brown paper. If my bin is out of brown paper, it means I am doing pretty good. It means I'm shipping a lot of stuff and not buying a lot of stuff. When my bin gets full of brown paper, it means I'm buying stuff and not shipping stuff.
We have the same bin. We track it via the same metric, unofficially.
It's a surprisingly good way of measuring things.
It is, and our bin is empty right now.
Oh, my bin is full.
We also have we have one of those Uline desks with the big cardboard sheets, or the not cardboard, but the big sheets.
Yeah.
Of that paper, the brown paper, and then like a big roll of foam. So we fall back on that, but we have that bin, and we try to use it up first. It is like Weston actually just commented this week. He's like, I wonder how much money we've saved in packing materials. Yeah. But
all right, I don't think any other Patreons have given us a question while we were recording, so I think
timing is perfect.
Here, let me turn on one quietly so you can do your outro. That's a terrible one to do. Oh, whatever. Just go for it.
All right. Well, guys, it's been a podcast, and we appreciate you guys hanging out with us as we kind of go through what we got going on in our worlds. Hopefully, you've learned something and or asked us some good questions that we hopefully answered well. And look forward to hearing from more questions from you guys. And this is Harrison with Precision Ingenuity signing out with AJ from Audacity Micro.
I'll make some more chill outros that we can do talking over.
Yeah.